have like looseness, and also check the prop tips for wear or damage. Ensure the assembly follows specification. For the last point is about preventive maintenance. Check and adjust servo motors and also the belt tension. Calibrate joystick to remove mechanical plate, and also inspect the column straightness. Is it for the squareness, bearing and guide wire. Test the voltage level, grounding, cables and connector. Replace aging electronic component if necessary, and also update the software and the backup machine data. That's the very important is backup machine data before updates. And then after the test, after the upgraded, you must test the machine to ensure the measurement accuracy. For the full calibration is about perform the prop qualification and touch head performance. Also conduct multi-directional surface scan at all the different speed. Perform the volumetric error mapping across working volume. Then you must identify linearity, orthogonality, rotation, and also the straightness error. Use the compensation tables to correct errors. You calibrate that after you do machinery relocation, major repairs, prop displacement, and also environmental disturbance, like if have temperature spike, and the other one is flooding, and also about electrical. Thank you.
For the first is metrology and blueprint basics. Operator should know, and before touching the CMM columns, operator must understand the fundamental language of inspections, like blueprints reading for ensure the operator can interpret engineering drawing through the blueprints and CAD data. And second, geometric dimensioning and tolerance GDT to train operators on how to identify datums through position and form tolerance. Second, measurement units to teach them conversation between metrics like mm and imperial inch and how to handle instrument resolutions. Second, CMM hardware and safety. Operator must know how to physically interact with the machine without causing damage the sensitivity probe or skills. Third, software proficiency in CMM is on the how to run specialized metrology software like PC, DMIS, Calypso and CMM Manager software that leading software package using to run column type and bridge coordinate measuring machines. This metrology platform acts as the brain of the machine, converting the physical coordinate movement of the CMM column into the actionable geometric data to inspection reports. And lastly, operator must know about hands-on execution and calibration. First, they should know how to move a theoretical training to supervise practical operations. Mastering in the joystick teach operators is how to manually jog to CMM column safety without using the automated CNC mode. Second, probe calibration is show them to how to calibrate by the probe tips by using standard calibration sapphires. And they should know the first part run that have the operator execute and establish and pre-written program under supervision while checking the results, And lastly, error troubleshooting that train them on how to handle basic software prompts, clear fault condition, and verify clearance angles.
So this section is about the CMM measurement. So there is 5 types for us to know how to measure of color measuring machine. The first one is how to setting the coordinate. So in every measurement process, setting the coordinate is the first step to do and need to be done so that the coordinate system being as a reference point on the color machine. Here are the steps to set up the coordinate. The first one is select the main datum, which is the base on the measuring table to be used as a reference. The second is set the X, Y, and Z axis on the surface or reference point to determine the movement of the probe during the measuring process. The last one is the probe is used to take several reference points to form the coordinate system. The second one is alignment. So alignment is important to ensure that the measurement calculation is correct and free of any errors. So take the reading on the flat surface of the column machine to ensure that vertical axis is aligned with the axis on the machine. And then use the alignment function in the CMM software to reduce the occurrence of positioning errors. And the last one is ensure that the probe is positioned correctly and is not tilted by comparing reading at the top and the bottom. Next is 3D measurement. So this column CMM can measure the 3D dimensional workpiece. Therefore, the following are the terms of how to measure the 3D material. First one is linear, and then geometric and form tolerance. So by linear, it's how to measure the length, width, and height of the material using a probe that will touch the end of the material point. Geometric will measure the diameter or radius of the material by taking reading around the circular at the material. And the form tolerance is the probe will take several points along the surface of the material to obtain the strengthness, flatness, or roundness value of the material. The third term is virtual projection. So virtual measurements are made to check whether the machine measurements are the same or not as the virtual measurement. So this ensures that the measurements are completely accurate. The first one is import the workpiece model via CAD software to the CMM software and then compare the actual reading using the CAD model to produce a virtual representation of a workpiece. And then use the specified function to see if there is a difference between the column calculation and the original design from the CAD. The fifth term is virtual image measurement. So perform measurement directly from the CAD model and then use the software function to measure distance, angles, or diameter at the design in the CAD without touching the physical object, and then compare the virtual measurement result with the established specification to check the material validation.
In this slide, I will explain the problems related to coordinate measuring machine or CMM. First is environmental and temperature fluctuation. CMM is very sensitive to temperature changes because the machine structure and the workpiece can expand or contract due to the heat. Next is dynamic and geometric errors. Over time, the machine structure may become slightly misaligned due to wear and tear or mechanical stress. Even a small misalignment can affect the 3D coordinate readings and produce inaccurate measurements. Another issue is probe and stylus limitation. If the probe is damaged, loose, or too flexible, it may bend or touch the workpiece incorrectly, causing false reading during inspection. Besides that, part setup featuring are also important. If the workpiece is clamped too tightly, it may deform, but if too loose, the part can move during measurement. And lastly, CMM has high maintenance and calibration costs. The machine requires regularly cleaning, maintenance, and calibration to meet ISO standards, which can be expensive and may also interrupt its production schedules.
My name is Nur Sharafah. My metric number is 240060. Today, I will introduce about my part is calibration methods according to ISO 17025. For the first one, environment and preparation control. It's because calibration condition must control by temperature, humidity, environmental stability, and also standard temperature is around 20 Celsius. Temperature usually should remain stable with a minimal fluctuation. machine must reach thermal before calibration, and the recommended humidity range from 40 to 60 Hz. Prevent corrosion, reduce dimensional change in materials, and also incorrect leveling can cause especially in a long measurement. 2. Uncertainty estimation. In every calibration must include measurement uncertainty calculation, compliance with the guide to expression of uncertainty in measurement, short form GUM. Common coverage factor give 95% confidence level and also assume a normal distribution of measurement result. Last point is about reporting and traceability. Usually, measurement artifact must be calibrated against standard from a National Meteorology Institute. Short form is NMI. Example, column cmm calibration is usually performed every 12 months. So, intermediate check help monitor instrument drift between calibration. Common reference artifact used from grade 0 gauge blocks, step gauge, and also calibrated sphere. Thank you.
For conclusion is CMM is for quality assurance and high precision inspections within the modern manufacturing sectors. Throughout these studies, we explore the foundational elements and the structure of anatomy, specialized operation modes, and the step-by-step process required to transition physical contact probing into the precise digital data. And then, the investigation underscores that achieving and maintaining high-level accuracy is strictly depend on the robust of safety precautions, daily shift, maintenance, operators' training proficiency, and rigorous adherence to international calibration guidelines such as ISO 10360 and ISO 17025. Thank you.